Friends, I am today honored to introduce the speaker of today's lecture, our friend Druv Raj Sinh Zala, the student of BSCM 503 Industrial Chemistry course. During the last 1 month, we have a very hectic and very active session on Professor Aharon Gedanken's lecture series 2022, in which over 19 students have already presented lectures on various topics involved in the regular curriculum of this course. And today we are going to have the last but one lecture on nuclear fusion energy by our friend Druv Raj Sinh Zala. And I invite Zala to take the stage and present to us his views on the future of nuclear fusion energy. What are the hurdles in harnessing the literally inexhaustible supply of nuclear fusion energy? How to overcome the hurdles and how we can take hold of the literally non-polluting green inexhaustible energy source called nuclear fusion. For your kind information, as you know very well, these are the reactions that are powering the sun that we see every day, inexhaustible source of supply of energy. The reason behind the energy that we receive from sun is the nuclear fusion reactions that are happening, that are releasing the energy in the form of heat. I will give the floor and stage and podium to Zala to continue further and talk to us and enrich us with the recent developments in the field of nuclear fusion energy. Zala, you are kindly invited to give your views on this problem.
My topic is fusion energy. The most basic level, a fusion reactor requires fusion fuel. In most cases, an equal mixture of hydrogen isotopes, deuterium and tritium.
Deuterium and tritium. Tritium. Please go ahead. What happened to the connectivity? Yes? Can you please make sure that the connection is restored? Please make sure that the connection is restored. Yeah, please help us, Yash, to restore the connection. You can please go ahead, Zala, with your phone. Hurdles will come. We need to overcome the hurdles. While delivering the lecture, in between the PowerPoint goes also, in between the computer becomes non-functional also. The presentation should be stored in our mind and we need to entertain the audience and complete the presentation. Go ahead, Zala, in whatever mode you want. Attention audience, your attention is requested because this is such a crucial and complicated aspect that the world scientists are trying to solve. Your attention is requested. Please go ahead, Zala.
At a much bigger temperature, of the ions collide together
Yeah. Force is required to overcome the barrier of mutual repulsion. There is great mutual repulsive forces that are operative for the fusion of the species that are involved in the nuclear reaction. Once the repulsive forces are overcome, we will have something called fusion, and as a result enormous energy of fusion energy. For each fusion event, nearly 28 million electron volts of energy is generated. For each fission event, 208 million electron volts of energy is generated. It doesn't mean that fusion energy is inferior to fission energy. In fact, fusion energy is superior to fission energy, because at the end of the day, we will not have the problem of spent nuclear fuel. Spent nuclear fuel is literally a white elephant that the scientists are finding a solvent to bury the spent nuclear fuel. Such a white elephant will not be there when you take up nuclear fusion. It's literally inexhaustible supply of energy free from nuclear spent fuel. That is why the world scientists are focusing to break this mystery. Please go ahead.
This nuclear reaction produces a large amount of energy, much more than was put into achievement. So in theory, the excess can be harvested and used to generate electricity.
What is HS?
Yes, sir.
What is HS?
Just ऐसा वर्ड से नहीं.
In principle, what is used? In principle, अब जो बताए ना, in principle, what is used?
This nuclear reaction produces a harvested and used to generate electricity.
Good. Continue, please. Yes, please make us the presentation open. We want to see the beautiful pictures. Open. I do not want to hear any stories. You are supposed to overcome all the hurdles. Please continue. We are not going to stop anyway.
But the temperature required to achieve the reaction is such that the plasma must be prevented as much as possible from touching the walls of its containment vessel to avoid melting or otherwise damaging it.
Yeah.
Theorists have calculated that the requirement for fusion ignition encapsulated in a simple formula known originally as the Gaussian criterion.
Good.
After British physicist John B. Lawson and later refined it as the triple formula. Inertial quantity.
Have you noticed, in spite of the problems Jala is facing, he has problem with health, he has problem with many things, but he has no PowerPoint presentation displayed, yet he is trying to give us something new. Go ahead. Yes, please try to open the presentation.
Yes. Inertial confinement fusion. ICF was first developed at Lawrence Livermore National Laboratory in California in the 1960s and 70s, and the laboratory remains at the forefront of the field. Its National Ignition Facility, NIF, is home to the most energetic laser in the world, and the 192 beams it produces are powered on fusion fuel target that deployed by the 2 megajoule laser pulse reach high temperature and high density conditions.
Yeah, the potential of lasers being exploited for fusing the, isotopes of hydrogen. Thank you. We are successful. Yeah. Yes, indeed you are successful. Good. Let us give a big hand to Yash for making the presentation possible. Yeah. Please please go near the podium and deliver. Jala, you can now the floor is yours.
Here's the figure of the impulsion process is complex and involves several stages. a fuel capsule and a plastic sphere containing deuterium and tritium fuel frozen onto an inner surface. It's about the size of a paper cone. Laser beam are shown in two holes, one at either end of the hole.
Excuse me, Jala, if you can see the projection, it will be easier for you to read. Okay, please. Yeah. Please see the projector and continue reading for us. You know, Jala, if you know, there used to be academicians with a specific name called reader. Today we have assistant professor, associate professor and professors in the academic institutes. In older days, you know, we used to have some academician like reader. Okay, we missed the bus. The reader is supposed to read to us the original text. This is the effective mode of teaching. You know, there are initially, you know, only two modes of teaching. One is to read the original document or to show your life example. The teacher should himself be a life example to the class, or he should read from the original text. Today we have so many texts, so many books that, you know, the original concept is diluted, and what we are reading is, you know, often, you know, diluted version or misnomers of the original text. You are supposed to do the job of the reader here, like a great academician, to read from the original text. Okay, read from what you have written and give your own ideas.
The important process is complex and involves several stages. A fuel capsule, a plastic sphere containing the
You should understand, fission is an explosion, fusion is an implosion. Go ahead.
containing the deuterium fuel frozen onto the inner surface. It's about the size of a paper cone and the position at the center of a gold cylinder about a centimeter long hole. I don't know how to pronounce it.
Holram. Yeah.
The laser beams are shown through the two holes, one at either end of the holram, so that the light falls on the inner hole of the cylinder, not on the capsule. The beams heat the holram material to high temperature so that it emits X-rays, and this shine on the surface of the capsule, causing some of the plastic explosively fly off the capsule, and so driving the rest of the capsule wall and fuel inwards toward in center at several hundred kilometers per second. If symmetry is maintained, the fuel will be compressed into a hole with a density 100 times that of lead and a temperature of 50 million degrees.
Can you read this once again? Dear students, your attention is called.
If symmetry is maintained, the fuel will be compressed into a hole with a density 100 times that of lead and a temperature of 50 million degrees.
Yeah. Can you imagine the temperature of, you know, not 50 degrees. We are talking of 50 into 10 power 6. 50 into 10 power 6 degrees, you know, I say million. I say million as a nuclear scientist, you know, but my engineering students say mega. Million means 10 power 6. Engineering students are teaching me to call it as mega, but I resist. I try to call it as million. You know, 50 million degrees means 5 into 10 power 7 degrees centigrade. Imagine the temperature in Korea now will be, you know, 5 degrees or so. Because I was in South Korea, I have enjoyed the beautiful climate. You know, even in China, you know, in China, you know, the temperature even in summer will not be more than 30 degrees. That is the beauty. Can you imagine? It's like Gujarat. You know, in Gujarat also we have the pleasant climate. You know, not more than 30 degrees. You know, I came to Gujarat lately. You know, in July. In July, you know, in Tamil Nadu or Andhra, the temperature will be very hot, nearly 40 degrees centigrade. Whereas in Gujarat, I was surprised to see that the temperature is 10 degrees lower. Maybe it's because of the, good plants, trees, ecology, nature. Nature is well preserved in Gujarat. It's not so in, South India, like, Tamil Nadu or Andhra Pradesh. The resources are overutilized, overexploited. Everywhere you see, urbanization, plantation of trees is minimal. These are the consequences, these are the reasons that are leading to ill consequences like, catastrophic environmental disaster, floods. Angela Merkel was shocked, Xi Jinping was shocked. Why to shock? It's expected. Why Xi Jinping should be shocked of floods? Why Angela Merkel has to be shocked of floods? These are known. When you go on cutting the trees, will there not be floods? When you are going to continuously exploit the natural resources, will there not be uncontrollable catastrophic climatic events? Why Xi Jinping has to be shocked? Why Angela Merkel should be shocked? Why Modi should be shocked? These are all hammered upon the head of these policy makers, politicians, by the scientists. I have written a book on, can biofuels alleviate the energy and environmental crisis? I am very sure neither Angela Merkel nor Xi Jinping nor Modi have read my book, because we have such administrators. Please go ahead.
According to theory, under this condition, a fusion work should begin in a box core at the center of this core and then propagate outwards, consuming all the fuel. This is aided by a process known as the alpha heating, where the helium nuclei or alpha particles.
You see how beautifully Zala is putting to us. He could simply write as alpha particle, as conventional scientists writes. But Zala is telling to us alpha particle means helium nuclei. Who knows what is alpha? I know alpha is the first letter of Greek language. Only that I know. Even for a non-nuclear chemistry student should be understandable. That is why Zala is telling that alpha particle is helium nuclei, He24. 2 is the atomic number, 4 is the molecular mass. Agreed? Atomic mass. Do not think that I do not know the difference between atom and mass. Atom is an atom, molecule is a molecule. Atom is not molecule. Oxygen is an atom, O2 is a molecule, chlorine is an atom, Cl2 is a molecule. I know the difference between atom and molecule. I know the difference between atomic mass and molecular mass. Please go ahead, Zala.
So helium nuclei or alpha particles that are the product of the fusion reaction fly off with high energy and some polymer eat the fuel to maintain the burn. Magneto inertial fusion. The two varieties of fusion examined and so far, magnetic and inertial exist at extreme ends of our parameters permitted by the Newton model. Extremes that are complex and expensive to achieve other approaches explore the middle ground between these extremes at more moderate levels of performance and density. Many groups are investing in the middle ground in the hope of finding approaches that are faster, simpler, and cheaper than the multi-billion-dollar facilities like IPR and NI. Other approaches, any company.
Yeah, you see, now Zala is telling other approaches. What is the approach that Zala has told in the previous slide? Students, are you following Ashish? What is the previous slide telling us? Magneto-inertial fusion. Agreed. I told you, among all, we have in our class the fat man and the little boy. We have the fat man, Harshit Panchasara, and we have the little boy, Ashish Mishra. We are blessed to have the fat man and the little boy. These two have highest inertia. In spite of having so much of inertia, they cooperated with me and they delivered excellent lectures without postponing on the schedule. Okay? Fusion. Coming back to the point. Magneto-inertial fusion. the inertia here is there is a repulsive forces. There are repulsive forces in the fusion process. We need to have the force to overcome the repulsive forces between the reacting species. Magneto-inertial fusion. Yeah, please go ahead.
Another noteworthy technology is formerly known as tri-alpha energy of food and ranch in California also uses FRCs but without the compression, instead attempting to prolong their life and so increase confinement time. The company's current device named Norman after the company's co-founder Norman.
Excuse me, Jala. Can you please tell us what are FRCs?
No, sir,
I might have read, but I have not followed. FRCs, fusion reactor. Can you please see the FRCs? Dear students, you are supposed to find FRC in nuclear fusion technology. What is FRC? I am trying to open the paper that I have sent to Jala. Functional residual chemistry.
chemistry.
Can you read out? Functional residual capacity. Functional residual capacity is the volume of air present in the lungs at the end of passive expiration. Functional residual capacity, the opposing elastic recoil forces of the lungs and chest. Functional residual capacity. Probably this is a different context. I will find out for you. Yeah, this is what I expected. Field reversed configuration. This is correct. Yeah, thank you, Yash. You proved to be a beautiful, scientist like me, Lee, Meitner, and Han. Yeah, do you follow? Please do not expect me to know 100%. You need to carry the banner. You need to carry the torch further. Okay, when I ask a question, I can tell you what is wrong, even though I do not know what is right. Agreed? Field reversal. Field reverse configuration. Yeah, thank you, Yash. Please go ahead.
His co-founder Robert died in 2014. In the later in a series of machines, each one increasing in scale and power. Norman is 25 meter long with a plasma injector at each end.
I will read out. Excuse me. I want to spend 1 minute on this field reversed configuration. Okay. Conventional field reserved configurations a field reversed configuration is a type of plasma device studied as a means of producing nuclear fusion. Okay, it's a type of plasma device. It's a type of plasma device used as a means for producing nuclear fusion. FRC, field reversed configuration. Yes, Jala, please go ahead.
The injectors in each fire of FRC inverts towards the center at nearly 1 million km per second. In a central reaction chamber, the two FRCs merge, converting their kinetic energy into heat to form a cigar shaped FRC about 3 meter long and 40 cm across. The plasma is held by
held there by magnetic fields.
held there by magnetic fields while neutron particles beams are fired
Tangentially
into the edge of the FRC to keep it spinning, stabilize it and heat it.
yeah
This is not a conclusion.
yeah
This is not a exhaustive list of all alternative fusion concepts being studied, but I hope it gives an idea of the breadth and diversity
breadth and diversity. Yeah,
diversity of the field. Just like with the Tokamaks, alternative fusion research have so far focused on the problems of reaching the necessary condition for fusion reaction to produce excessive.
once that is achieved,
These approaches like Tokamaks will have to overcome many engineering challenges before they can build a power generating reactor, including how to extract heat and generate power, how to limit damage from neutron bombardment, and how to use those neutrons to build
tritium to use as fuel. Yeah,
tritium to use as fuel. Being smaller, faster, and cheaper does not necessarily make those problems easier. As another dose of reality shows how Tokamaks have improved their values of triple product over the past few years compared with several recent entrants of the field.
yeah.
Let's start of how it was now.
Fusion triple products. Tokamaks, ITER projected, Lockheed Martin, Tri-Alpha, General Fusion, Fusion triple product. What is DT there? Deuterium, tritium. Okay, D2, T3. Okay, break even Q is equal to 1 up to 2022. Where have we reached? Okay, ten power 20 into 10 power minus 10 power 20 kilo electron volts second per meter cube. Much time has to be spent on understanding, the y-axis, the parameter that is shown on the y-axis. Okay, and the projected target is shown here. Ten power 20 kilo electron volt second per meter cube. You see, per a specific volume, what is the energy output that is expected? Can you read for us the conclusion page once again, because it has reference to this figure?
This is not a exhaustive list of all the alternative fusion concepts being studied, but I hope it gives an idea of the breadth and diversity of the field. Just like with the Tokamaks, alternative fusion researchers have so far focused on the problem of reaching the necessary conditions for fusion reactions to produce excess heat. Once that is achieved, these approaches like Tokamaks will have to overcome many engineering challenges before they can build a power generating reactor, including how to extract heat and generate power, how to limit damage from neutron bombardment, and how to use those neutrons to build
Tritium to be used as fuel. Yeah.
Being smaller, faster, and cheaper does not necessarily make those problems easier. There's another dose of reality. Figure 7 जो चार्ट हम अभी देख रहे हैं.
How Tokamaks have improved their values of triple product over the past 50 years compared with several recent entrants to the field. Here there is something called, as chemists we are familiar with, triple point of, water, triple point of, sulfur, triple point of something. Here we are reading something different. This is what is called triple product, and it's as significant as the little boy and the fat man. Yes, can you please read for us what is triple product? Triple product. We have just now seen field reversed configuration is a type of plasma device that is used as a means for producing nuclear fusion. Likewise, let us see what is, triple product. In spite of myself being an expert in nuclear science, I have left this field 20 years ago. So I need to read the recent developments. That is the very intention with which to share with you the recent developments during the past 2 decades. I wanted this presentation to happen. Yeah, triple point. Can you read, Jala?
Yes.
Read out, please.
In geometry and algebra, the triple product is a product of three-dimensional vectors.
Yeah, triple product is a vector of three-dimensional vectors. Here, what are the three vectors?
Triple vectors are temperature, density, and time.
Temperature, density, and time. Temperature, density, and time. Yeah, that is what we are seeing on the plot. You see triple product. We are seeing something called density is mass by volume. On the denominator we are seeing the volume. Okay, density is mass by volume. Here we are measuring temperature, density, and what is the other one? Mass. Yeah, time. If you carefully observe the units on, can you go to the next plot? This is, thank you very much, Yash. Thank you very much, Jala, for introducing to us the triple product. All things, that may be trivial to Yash and Jala may not be trivial to me. I have no shame, if I do not know anything, I say I do not know and I will learn. Okay. Triple product in algebra and geometry is that is the product of, can you read out once again, Jala?
It's a product, नाम बोलो तीनों product.
Triple product. Once again, read for us. Triple product. Algebra. Not algebra. you are making me smile.
In geometry and
Algebra.
the triple product is product of three-dimensional vectors.
Yeah.
Time, density, and temperature.
Yeah.
Density.
Please remember, in geometry and algebra, triple product. For your kind information, I studied mathematics up to 2000 while I was a graduate student like you, or like you. 2000 I stopped studying mathematics. From then I started using mathematics for chemistry. You may be surprised, I have never ever heard the name triple product. No surprise, no shame. Why should I feel shame? Okay, if I do not know anything, I do not know and I will learn. Like that, it should be the attitude adopted by you. You are not expected to know everything, but it is expected of you to learn new things each day and become chemists. Okay, chemical engineers, professors, scientists. That is the way I have grown. For past 2 decades, I have published 44 papers. Do you think without reading, without learning anything new, I have published 44 papers? If I were to feel shame that I do not know triple product, that is the end of it. We should not get depressed. We should not get, discouraged because we do not know something. It's an opportunity given to us to learn. Such a wonderful plot, Jala is showing really, the y-axis shows something related to, the triple point, fusion triple product. Sorry, it's not triple point, it's triple point. Fusion triple point. Fusion triple point is the product of, temperature, time and density. Density is mass by volume. That is what is shown on the denominator. Volume. What is the unit of volume? Yeah. Volume of a cube. Volume of a cube is a cube. Agreed. That is what we are seeing on the bottom. Okay. Volume of cylinder 2 pi RL plus 2 into pi r square. That is surface area. Total surface area, lateral surface area 2 pi r. What is the volume of cylinder? Someone? Volume of cylinder 2 pi RL plus 2 pi r square is the total surface area of the cylinder. When we talk of nuclear fusion reactors, we have different geometries, cylindrical, cubic, exotic, spherical, yeah, tokamaks, yeah. Anyone? Pi r square h, pi r square into height. Is it not the lateral surface area? I asked volume. Pi r square. What is the area? Huh? Pi r square is the area of circle. Area of cylinder. What is the area of cylinder? What is the volume of cylinder?
Volume of cylinder will be pi r square h. Volume of cylinder pi r square h.
Okay. Okay. Please think of that, something here we have some parameter called, fusion triple product and how tokamaks have, been gradually, progressing in this field from, 1960s to 2022. Please see the parameter. Fusion triple point. Here we have something, the product of, temperature, time and volume. Okay. Thank you, Jala, for introducing us, something new, and we are thankful to you for, for the eloquent lecture. Thank you, audience, for, presenting yourselves, and thank you for the attention. Any quote? Yeah, please read us. Jala, is it your personal quote? आपका personal quote है क्या? पढ़िए ना.
Many in these fields argue that concentrating so much money on one approach, tokamaks, while others are so poorly supported, is not healthy. Fusion is too important for it to be limited to a single approach. There is a diversity reduces the risk.
Thank you for the quote. Have you understood, students? What is the conclusion is tokamak is not the panacea for harvesting, fusion energy. Okay, diverse approaches need to be adopted. Let us give a very big hand to Jala for the nice presentation. Thank you, Jala.